Morning, gem friends. How are we doing? This is the 4th week of the London lockdown. I hope you had a great Easter. It's a lovely day here again, here in Darkhurst, Marylebone. The skies are blue. We're ready for a bit more gems. And today we're going to do a bit of gemology as well as having a little game. Last video we looked at natural greenstones from emerald through to demontoid. Naughty one, doesn't want to play ball. Today we're going to look at stones grown artificially to look like these natural stones. Now here we start coming against terminology. Gemologists learn to use the word synthetic. It's an adjective, not a noun. So these are synthetic stones. They're grown artificially. Now, stones which are grown artificially and have the same, the same chemistry, the same chemical makeup, the same optical features of refraction and dispersion, and the same physical properties like hardness and chemical structure. We call those stones synthetic gems. So diamond has a synthetic counterpart, which is getting terribly popular at the moment. Emerald, ruby, sapphire, many gems have a synthetic counterpart. But those gems that just look like a natural stone, but don't have the same chemistry, the same optics, the same physical characteristics, they just look like it. They're called imitations or simulants. Confused? No, you're not. They're just, I'm going to use the term man-made, not in the gender sense. But I think they are grown by man. So, man-made gems. I've used that term for decades when I've been teaching diamonds, and no one's got upset by it. Certainly not any young ladies in the room objecting to my use of the word man. I digress. This stone here has got the lowest refraction. This is glass. Green, it's transparent, it's oval, mixed cut. If you don't understand what the word mixed cut means, we're going to look at styles of cutting gems on a later video. It's one of the oldest simulants that we know. Glass has been used to imitate natural gemstones for thousands of years. But glass does come in a natural form. This is natural glass. And it's produced not by an extraterrestrial, it's produced when a meteorite from beyond the Earth strikes the Earth and creates this natural glass. Now this one, I wonder if you can see the structure on there. Perhaps not. But if I use my trusty ancient iPhone, you may be able to see, oh yeah, look, it's green and transparent. You can see the surface structure there, which is very typical of this material, moldavite, when it's found on the Earth surface. We can cut that and we produce faceted moldavites, as these fellows are. But again, I'm digressing, so let's go on to the second. Did I tell you the refractive index of this glass? It's singular refractive. And its refractive index, looking at my notes, is 1.49. totally different from very low refractive index, totally different from any green, natural greenstone I can think of. What do you think that's imitating? What natural gemstone? Emerald? Tourmaline? Who knows? Cheap as chips. Push him off. Now this fellow is more interesting. This is synthetic quartz. Let's get the light off there. It's got a high refractive index. So being synthetic quartz, it has the same optical properties, refractive index, as natural quartz. Or does it? It does. This has got a refractive index of 1.5, mean RI of 1.55. Now, this is grown by the hydrothermal method. Basically, you get the constituent material of quartz, which is of course silica, shove it in a closed system, dissolve it under pressure in water, hence hydrothermal, high temperature, and then it crystallizes in a cooler, separate place of the closed system, and we get synthetic quartz, green. You may know that a great amount of citrine is man-made, synthetic. This fellow is synthetic citrine, large stone. So the green, transparent, step cut, trap cut. If you remember one of the first videos, what is another name for a step cut? Trap cut. Synthetic green quartz, grown by the hydrothermal method, as is this fellow, grown by the similar method, but this has got a higher refractive index. It's got a refractive index of 1.57, which is not dissimilar to this fellow, which is natural emerald, Brazilian emerald. This is synthetic emerald, man-made emerald, again grown by the hydrothermal method. Now can you see that fellow there? How do we tell the difference between synthetic emerald and natural emerald? Relatively straightforward. Different inclusions, different refractive index. This has got quite a low refractive index for an emerald. Or refractive indices, I should say, as it's doubly refractive as the quartz is. So in another video in future, we're going to look at refractive indices, how to determine them and how useful they are. Still useful in the age of high-tech gem identification. And let's go on to the last stone with the highest refractive index. Let's put my Brazilian emerald back. Guess what this is? It's got a refractive index past the scale of a standard refractometer. That scale ends at 1.81, of course. This has a refractive index of 2.18. This is synthetic cubic zirconia, which is a cheap imitation of diamond, of course. But here it's been coloured green to imitate, well, what? Emerald, Zavarite, Demontoid. Who knows? CZ can be grown in various colours. And here, my glamorous assistant will hand me a bag of different coloured cubic zirconias. Pink, he said, holding it up. Pink, yellow through purple. Cubic zirconia, different colours. So, ladies and gentlemen, boys and girls, that's the answers to our stones today. Glass, synthetic green quartz, synthetic hydrothermally grown emerald, and synthetic CZ, which you gemologists know is grown by the skull melt method. So that's enough for me to, no it isn't. I wanted to show you this emerald. This is a synthetic emerald grown by the flux fusion method. Has a different refractive index, mean refractive index, to the hydrothermal. Different inclusions. Not a problem identifying it. So another synthetic emerald. And this fellow here is an assembled stone, a composite made of 2 or more parts to look like a fine emerald, as it does. But actually, this is a sandwich of 2 colourless materials of quartz, like the 2 slices of bread, and the gem in the middle. I wonder if you could see that now. The way I'm doing a bit of gem testing here doesn't really work. Maybe. No. Actually, the best way to do it is to immerse it in water, and you'll see the colourless top or the crown of the stone, colourless pavilion of the stone, the assembled stone, and the girdle area is coloured green by a green material. Face up, it looks like a rather nice emerald. So this is a composite stone, an assembled stone, and I was taught this example is a Soudet emerald. Soudet, I think, is French word for soldered. Maybe wrong there. It's another quiz. What does Soudet actually mean? Thank you, ladies and gentlemen, boys and girls. That's enough from me today, and we'll have another video in the next few days. So keep healthy, keep inside, keep safe. See you soon.